start.
All right, guys, let's do our daily warm-ups.
No.
Ready?
Can't do it. The math figures. Can't do it.
All right, I'm ready.
Okay, we warm?
We're warmed up. Let's go.
Good?
I can't do it,
Alright.
to be honest. I struggle with it.
Alright guys, notes today. We're going to start chapter 10. We're only doing a couple sections out of chapter 10. Just so you can get a feel for two sets of data instead of one single set. Okay. So chapter 10, be sure that you read 10.1 and 10.2. And today's lesson will be fairly short.
Whoa.
Alright, who's my reader?
No good.
Go ahead, Tanner.
In this chapter, we introduce methods for determining whether a correlation or association between two variables exists, and whether the correlation is linear. For linear correlations, we can identify an equation that best fits the data, and we can use that equation to predict the value of one variable given the value of the other variable. In this chapter, we also present methods for analyzing differences between predicted values and actual values.
Okay, so we're going to look at two data sets here, and we're going to determine whether or not we have a correlation. So the title of 10.2 is correlation. Okay, so what your calculator is going to do for you, so you have to be patient and you have to make certain that you enter the data correctly. Your calculator is going to compute the value of what we call the linear correlation coefficient, and we will give it the letter R. Okay? And it is a number based on your data, and it will measure the strength of the relationship between your two variables. Okay? So for instance, do you think there is a relationship, some relationship, between a person's height and their shoe size?
Yes.
What would you think that relationship would be?
Taller person with a good shoe.
So as one goes up, the other goes up.
Yeah.
Now, is that true for all people?
No.
No, but in general, it seems that there would be a correlation. Now, we could go around and we could collect data. What would the two things that we would need for a person?
Height and
Height and shoe size. We could actually put it into our calculators and see if truly mathematically the number tells us that we have a correlation. Okay? So that's what we're going to look at. This is called paired data. Sometimes it's called bivariate. Okay? So bivariate would be paired data. So we're going to use technology to find it. It used to be in the day we would do it by hand. Okay, we're only going to consider linear relationships. There are other types of relationships. There are ones that look like a parabola. Okay, we have what we call a logistic relationship. We are only looking at the linear, okay, in this chapter. So here are your basics. A correlation exists between two variables when the values of one are somehow mathematically associated with the values of the other. As the height goes up, the shoe size goes up. So a correlation. Values of one variable somehow mathematically are associated, not affect. Do not say affected. They are just associated with the values of the other. Linear correlation coefficient R is going to be a number from the sample. Please be aware it is only from those numbers you type into your calculator. It's not for the whole population. All right, way back when you first learned statistics, you learned mean, median, mode years ago, and then maybe to be advanced from that, then you did what we call a scatter plot. Now your scatter plot is an x-axis and a y-axis, first quadrant, and dots that represent your paired data. Does that make sense? You've seen it before? Okay? So here are from 2 technology sources. We have scatter plots. Now, if you notice, these kind of are tending to go up as we go left to right, aren't they? This would be the idea of the height and the shoe size. As one variable goes up, the other increases as well. This is called a positive correlation. Now, the value of R that your calculator would give you when you input the data would be a number like this. Very large decimal value. This one is a negative correlation. As the x value or the horizontal value goes up, the other variable tends to go downward. So if you think of your lines, remember in algebra, graphing lines, this would be a negative slope. Notice it's negative. See the decimal value. We're going to see what that decimal value means in a second. So those are your scatter plots and kind of what they look like. Here's one. Those dots are just all over the place. Doesn't look like there's any correlation at all. So your correlation coefficient R will be 0 or close to it.
What was the positive one?
Well,
I'm sorry.
and that's fine. It just, the thing we pointed out was that this value of R is close to 1. And that looks pretty strong. This looks like a pretty strong negative 1. And look at the value of the decimal, close to negative 1. And then looking at this one, we don't see a relationship at all, so our coefficient is close to 0. That makes sense there. Check that out. Definitely a correlation, yes, but not linear. Okay, and we're only dealing with linear. Okay. These are already taken care of for you on your data. We might have to look at the scatter plot to see if it looks like it's got a correlation before we begin. So your sample XY has to be a random sample of quantitative data, meaning, what's quantitative again?
Numerical.
Numerical as opposed to qualitative, which would be
Analytical.
more like, yeah, names or descriptions, okay. Okay, a visual examination of the scatter plot must confirm that the points have some sort of straight line pattern. If they don't, we're not going to bother calculating R. The outliers must be removed if they're known to be errors, okay? So we'll kind of tell you if it looks like an error or not. The effects of outliers should be considered. So if you have an outlier, folks, do the problem with it in, see what happens to R, and then throw that outlier out. Do the problem again, and see how R is affected. That's all that number 3 is saying. Now I included this slide in here just so that you could feel really, really lucky with technology. Because this is how you calculate R. This is how your calculator is doing it. It is this formula. And it looks pretty lengthy, doesn't it? So let's just read it, because part of being a statistician is being able to read formulas. Just a little bit through here. What does this mean to do here?
X times
Take each x times its y, right? And then that means add them all up, and then finally, and this is the number of ordered pairs, okay? The number of ordered pairs. Great. So imagine doing that by hand. Now this is add up the y's, add up the x's. You've got 2 numbers then that you're going to multiply. Then you subtract, you have your numerator. Now check out the denominator. They're identical, only this one contains x and this one contains y. Now that is a long calculation by hand. Our calculator will simplify it immensely, but this is the formula that will be used. And remember, this is from a sample. Our computer software or calculators will do it for us. Please round R to 3 decimal places, 3 significant digits, because we are going to use a new table today and we need to be able to compare it accurately. So, 3 decimal places, please. Tenths, hundredths, thousandths. Okay, here are some properties. I know that you're just itching to calculate it. We'll do it here in a second. Here are some properties of this number. Our correlation coefficient has to be between -1 and 1. What did you see from the screen just a little while ago?
The closer they get to 1, the stronger the correlation.
Closer to 1, the stronger the correlation. On this end, what kind? And on this end? And the closer into the middle, around 0? No correlation at all. Very nice. If all values of either variable are converted to a different scale, the value of R does not change. Now, what this means is, let's say that Emily over here decided to put the height as X and the shoe size as Y. And over here, Clayton decides he's going to switch them up. In the end, it does not affect the value of R. Okay? So don't ask which is dependent, which is independent. It's okay. You just need to know which ones you entered where so that we can answer questions about it. That's all. The value of R is not affected by your choice of X and Y, and that's the same right there. And R measures the strength of the linear relationship. We talked about outliers already. Okay, this section we will apply to the following section. As with all the others, we're only going to do one more after this section out of chapter 10. Okay, here's a nice one. I want you to have this in your notes. How about another reader, please? This is actually your book problem. Chapter problem in the book. Anybody want to do?
David wants me to read.
They're right in front of me.
Yeah, there you go.
Example. The paired pizzas or Subway fare costs from table A1 are shown here in table A2. Use computer software with these paired sample values to find the value of the linear correlation coefficient R for the paired sample data.
Okay, requirements are satisfied. It's a simple random sample. Look, cost of a slice of pizza and Subway fare in dollars. Here's some cost of pizza and the Subway fare. Wherever this cost of a piece of pizza was 15 cents, Subway fare 15 cents, actually in dollars. So it says 0.15, doesn't it? Yes. 0.35, 0.35, 1.1, 1.25, and so on. Okay? This table is actually in your book. TI 84 plus scatter plot approximates a straight line. So I want to show you this graph. Your calculator will do this for you. We will do one here. So there it is. Now does that look like we've got some sort of linear relationship? What kind? Positive. Looks like it. Okay? So here's what we're going to do. On your calculator, if you would turn it on, please. Go to Stat. We want to go to the lists and clear them out. Do we have a clear list?
Yes.
All right. Stat 4, clear list, enter, enter. Should say done or something like that.
Error.
It did? Anybody else get error? Nope. Okay, what you'll need to do, go into Stat, Edit,
Okay.
arrow all the way up to the top of your list,
Yep.
and hit clear, and then arrow down and it should have cleared it.
Yeah.
Okay, do that to 2, L1 and L2, list 1 and 2, okay. Anybody else get an error? Okay,
Go ahead.
so guys, we want to enter in list 1, or if it's named something else, look at the name of it. And we want to enter these numbers. Can you see them okay? I can go back to the other one. And then in list 2, those. more time, entering. Pretty close. Oh, look at the stat key. Oh, I heart stats. That's for you guys, okay?
Thank you.
You're welcome, no problem. Okay, go to your second key. Y equals, which is a stat plot up above by the window. Y equals stat plot. Okay. Enter twice to turn this plot on right here, this first plot. Then select this graph right here, which is your scatter plot. Okay, if you have just entered the data you want to use, there's no need to tell it to use these. But go ahead and hit zoom stat 9, so zoom 9. Make sure this does say list 1 and list 2, or whatever you have named them. Now you can choose an X, a dot, or a box for your mark. Okay, I chose the there. Okay. Were we successful at getting the same scatter plot that I have? Okay.
Yeah, except for one thing.
Except for what? You got another graph on there?
Yeah.
Okay.
Like I have the box or the box plot.
Okay, go to, same thing here, your stat plot, and you'll have other plots, plot 1, plot 2, plot 3. Make sure those are turned off, okay? The only one you want on is the one that we're doing the scatter plot. Let me know if that works, okay, Austin?
Oh, yeah.
Okay. All right, there's how we get the scatter plot. Now our graph shows there's an apparent linear correlation. So we're going to now calculate R, okay? And then we're going to run a test on R. So if you go back to your stat key, arrow over to calc, which is calculate up top, instead of edit, it's calculate, right? We want the number 4, which is linear regression, linreg, ax plus b. Calculate, hit enter. Now hopefully you have a y equals ax plus b, then a, b, r squared, and r. If you only have a, b, let me know, and we have to hit something to get everything displayed there.
Yeah, I only have it.
Okay? Try this. Those of you, sit patiently if you have those. Okay? So, go to catalog, which is going to be the 0 key, and it's blue, so it'd be second 0. Okay? And then go to diagnostics on, arrow down to diagnostics or stat diagnostics on, either one of those, and hit enter. Can you find it?
Diagnostics.
Yep,
Yeah.
diagnostics on. We want it to be on.
Okay.
That should do it.
Sure.
Now go back and redo this right here and see if you don't, because R is the thing we're trying to get at, so we gotta be able to have it tell.
I got R squared though.
Nice, nice, nice. Anyone else? Okay, so here's the value of R. Now remember, we're going to go out to 3 places, so we're gonna have to call it 0.988, are we not? Okay? So that is for our data that we've entered. Now here's how we decide if we have a correlation or not, based on our numbers. We're going to use table A6. Get your tables out. Table A6 is a brand new one. It's fairly small. It's off in the corner. Everybody see it? It's just a small one off by itself here. All right. So it deals with N, and then we have to know the 2 levels of significance, either an 0.5 or an 0.1. Okay? Now these are the ones we're going to compare to. So if you take your R, positive or negative, we'll go with its absolute value. If it exceeds this critical value in the table, we will conclude there is a linear correlation. Otherwise, there is not sufficient evidence to support the claim that there is a linear correlation. Everybody good at how we answer?
Well, so what's the significance level in that problem?
Yeah. What's the N on that
N is a number of ordered pairs.
problem? So six.
Six, did it have six? Yep. Okay.
It's not N minus 1 in this case?
It's not degrees of freedom, it's just what N is.
And what was the levels? What was the significance level?
Let's go 0.05. That's on the next screen here.
It exceeds it.
Okay? So, N is 6, 0.05 significance level. We have 0.811. Everybody see that? Right there. So what was our R? Our R, I should say. Right. So, since our R, that's hard to say, our R, right here, I think I got it going.
You got it?
Yeah. 0.988 is greater than 0.811. So we will conclude, thank you, there is evidence to support the claim of a linear correlation between cost of pizza and Subway fare. As Subway fare goes up, so does the cost of a slice of pizza, is what we're concluding. All right? So, if you would, just to get the hang of it, let's do one more very quickly. And then you got the time to work with your calculator. Between now and tomorrow, if you need to come in and work, feel free to come in and work. I'll give you a pass if you need to. So we're going to do one more, and then we're going to talk about one little concept, and we'll be done.
I like this chapter.
It's a quick one.
I like calculated work.
I do too.
Refer to data set 16, appendix B.
Yep, I believe it's, hang on, what do I have here?
That's a lot.
Hey, we've got technology on our side.
What? Jeepers.
Page 784.
I have like 20 of those back.
Oh no, your thumbs are gonna hurt.
Yeah, I'm looking forward to it. Next,
Me too. Get to her there, David. You heard the guys. You got a lot of thumb work ahead of you.
I can't wait.
The weight and the length.
And the braking.
It's two different columns. Weight of the car and the braking distance. So what do you think before you start?
Count them.
You thinking there's a correlation?
I don't think so. Yeah.
Don't think so? You do think so.
I think that
Correlation.
Yeah, I think that.
Which one is the correlation between weight?
The weight of the car and the braking distance.
I think.
Yeah. I think you're gonna find one. I don't know how strong it's gonna be.
Well,
But I do think the heavier cars have, like Matt said, have a longer braking distance.
seems like the length stays similar, but they'll still go down a little bit.
We'll see after we get it all entered.
It'll take a while.
Not really. I trust you.
Problem.
Problem is, you don't wanna make a mistake.
I
That's
feel
it.
like
Was it a million numbers you have to put in?
No, about 40.
Okay, that's close. Yeah, you got times it. Oh, I made a mistake, go back.
Oh, my brain.
67 you have to put in here. Oh my
How
goodness.
you feeling?
My brain is getting so low.
You still think I threw something at you?
So far, I don't think you have to think a lot, do you?
Have to focus though.
Well, focus, a little different, yeah.
Dang it.
My ADD, HD kicks in. I can't enter numbers very well.
Weight and braking.
Yeah.
It's a race.
Starting to get like,
It's not.
I'm
starting to get like, weird. We'll pass that up.
Yeah. I'm gonna throw up in
You're
here.
so cheap.
This is bad.
You know what's gonna suck if I lose, like, on the spot?
Oh, yeah.
Anyone on the next call? Probably.
So look at Dave and his technique up here. He's got the one going down and he's got it laying flat on his desk and he's punching it with one. And then he won't
Well, you know
lose.
what? Good for you, Dave.
Woohoo! Check that
I'm
out.
gonna patent it.
Oh, Emily stole it from you.
This
She's
way
doing
is
the
so
same thing.
Sure.
Although she's using more than her pointer. She's doing the typing hand.
No.
Yep, yep.
I can't do that.
Well, I think she's got skinnier fingers too.
Next call.
I missed one.
Now, I believe you can insert.
Uh-oh.
If you miss one, there's an insert. Do you see that INS?
Yeah?
Okay. So you don't have to clear everything out. You can insert it wherever you miss it.
40, 20.
So how would you like to be a number cruncher, huh?
No. Finished?
Oh.
Alright, so now I do stat plot. I can't remember. Stat plot. Make sure that's on. That's all good. Crap.
You want to look at the graph first.
Zoom 9. There's, ooh. Either I did something wrong or there's no correlation.
That's right.
Let's see if I can figure out what it actually is.
Bless you twice.
I got R to equal 0.086.
I got-
Ooh, that's not very strong.
I got
is
R
it?
to equal negative .04.
What?
We got it.
That might be right.
Don't say we got it. I'm so.
Negative.
So guys, make sure
No,
you
we
check
didn't
out
check.
your, make sure you check out your scatter plot. Okay?
What the heck? My scatter plot, yeah, that's nothing. That's nothing.
I
What'd you
told
get for
you.
R?
Oh, wait.
I told you.
087.
That's right. Austin said, I
Wait, what
told
do
you
we
there's
got?
no correlation.
We calculate it and then. Let's take it.
Yeah.
Show me standing out awesome.
So,
Oh no, I got a correlation.
are we still entering
Oh boy.
Oh.
scatter plotting?
Matt, what does yours look like?
Yeah, I had to have messed up.
Is that wrong?
I had to. Let's give it
That
out.
was good for your
Oh, did you do Zoom?
I have a positive
Yeah.
correlation. And my box plot thing is
My
back.
R is.
So your scatter plot shows it looks like there's a positive?
Like, yeah, like,
Yeah, 1.087.
yeah.
Are you
kidding me?
Yeah, there's a legit positive, like, it's pretty slanted.
I messed up.
Did you do the weight or the length?
I did weight and breaking.
I did weight, oh no. I did weight and length. I did the wrong column.
Well, I mean, at least that has a positive correlation.
Oh yeah, ours is negative. It's negative.
No way.
What did you guys get?
Oh
my God.
Negative point zero
I
eight
figured it out.
seven.
Time out. I figured it out.
Did you miss one?
I did.
No, I didn't
No,
put in enough
I did the
flipping
wrong-
numbers.
I did the wrong column.
Zoom 9.
Okay,
That
I did
would've
miss
been
one.
a lot
I
better
must
than
have
that.
voted
You
twice.
didn't miss one?
I must have
Stat,
voted twice.
calc,
for the
Could
first.
be.
4,
It's okay, Tanner, I did the wrong column.
negative .08.
Guys, I want to point this out because it's very important.
Yes.
What was it, point zero six?
I guess it's in my way, I'll have to rewrite it. See this INS key and the DEL, you might need them, delete or insert. So if you put your cursor in a list, okay, and you hit insert, it should move everything down, okay? Or if you want to actually delete one, because you entered it twice by accident, you can delete it. So that will be helpful to you. Okay. So, what do you think, guys?
Easy.
Doesn't look like it's very strong.
What's the critical value?
What did we say, negative 0.087?
Yeah.
It's negative. It's not very strong. Let's see if statistically we can claim there's a linear correlation.
Wow.
So go to your table A6. Anybody count how many we had?
32, Matt's got it.
32.
On each side?
Or 32.
32 ordered pairs is what we need. So 32 ordered pairs,
30.
0.05. Oh, we have 0.05.
0.05,
361.
0.05 level.
It's
361.
Just not. The table.
Now remember it's,
Oh, I mean,
we want absolute value, so we gotta compare 0.087 to 0.361.
Is that
Does it exceed?
No.
No, so our conclusion is,
no correlation exists between the
I don't know, evidence to suggest,
Correlation.
right.
just like the last chapter you want to put a correlation between.
Yes. I will tell you what, on the quizzes, that just really looked nice when you answered it that way. It just brought the problem to life. It really did. Yeah. Okay, a correlation between,
Eggs.
no, silly, this problem,
Wait.
the weight of a car and its braking distance. Okay, very nice. Okay, one last thing and I'll give you your assignment. Now here, this is kind of big here after I, oh my, I don't know where it went. Oh, you know what? It's probably this. There it is. Correlation does not imply causality. Guys, this is not a cause and effect thing. Okay, you have to be careful to interpret it that way. And here's just one of many examples. There is a negative correlation between the amount of time spent on social media and GPA. There's a negative correlation. So that data would suggest what? More time on social media, the lower the GPA. But that does not imply that if a person spends, it should say spends many hours on social media, then their GPA will be low. There are other variables that may contribute to a low GPA. So you can't say just because you spend hours on social media that you're going to have a low GPA. Be careful, it's not cause and effect. There's your assignment. Now I would highly recommend that you write down for each of these green ones here, the A, the B, and the R, because it would be a crying shame to have to re-enter them on the next assignment. In the list, it gives you A, B, R squared, and R.
why?
So if you write them down now, you won't have to re-enter, okay? Yeah, and I'm not sure if we'll cover all of them, but those are the section where it does say in the directions to write down things, okay? So 1 through 11 odd, 15, 19, 23, 27, 31, and write down A, B, and R for those that I have put in green. No. Those first 1 through 11, I believe, are just talking about your reading. The other ones are computation. Okay, do we need to warm down now?
No.
No warm downs?
No.
Okay.